Welcome back. I'm Ms. Killen here at MPB. We're going to jump on into our Unit 6, Lesson 2B of our Introduction to Quadratics. We are quadratic equations, and we're factoring those quadratic equations where my a is greater than 1. We're looking at SSE 3a and SSE 2. I can factor quadratics by grouping and by using the distributive property. So let's go ahead and jump into this. The first thing I want us to do is review. Let's review what we did when we had just a quadratic where a equaled 1. So I took the factors of my c that did my second operation, which was add, that gave me my b. So the factors of 5 are 1 and 5. So I'm going to take those and build my two binomials. So I have a 1 and a 5. My second operation tells me that both of my binomials have the same as the first operation, and then I have my x and my x. So there are my two binomials that I get when I factor that trinomial. Now, let's look at this one. This one looks a little different, but that's okay. We always do what when we're trying to factor? We always try to find the greatest common factor. Okay, so let's see if we have a greatest common factor. I have a 2 as my A, I have a 14 as my B, and I have a 24 as my C. Well, all of these numbers are, yes, even. So I know that 2 can be divided into all of them. So I'm going to pull my 2 out and write what's left. 2 divided by 2 is 1, so I have x squared. 14 divided by 2 is 7, getting ahead of myself. And then 24 divided by 2 is 12. So I'm going to keep this greatest common factor outside of my parentheses. I've always told my students it's kind of like bad luggage. You can't get rid of it, you just have to drag it along with you. So that's what we're going to do. We're going to drag that 2 along with us. So now we're going to build our two binomials. To do that, what we're going to do is we're going to find the factors of 12 that will add to give me a positive 7. So let's find those factors. I have 1 and 12, 2 and 6, 3 and 4. Which pair will add to give me that 7? Yes. So I have 3 and 4. My second operation is a positive, so that means both of my binomials are going to be the same as my first operation, and then my x's. So my answer is 2 times x plus 3 times x plus 4. So I had just a regular trinomial that I just had to get the factors of c to get my b. Then I had one where I had to pull out a greatest common factor so I could build my two binomials. So we want to make sure that we are remembering all these processes that we've done. So let's look. When I have a quadratic equation, and here's my quadratic equation, and my a is larger than 1, and I do not have any greatest common factors that I can pull out, I can use the process what is known as bottoms up. Now, that's just a name that someone has put to it. The way that we factor expressions where a is more than 1 is called bottoms up. Part of the process gives the name, and we'll see that in a minute. We always want to make sure that we look back at how we factor our trinomials and take that with us. So when I get to the bottoms up portion, I am going to take my a and multiply it into my c. I'm going to get the factors of my new c and then follow how I factor those trinomials. I'm going to create two binomials. If the second operation is plus, we know what to do. If the second operation is subtraction, we know what to do. And then I'm going to factor my trinomials as normal. We started the process by multiplying my a into c. So we always have to put things back where we found them. So when I want to take my a out of my c, I'm going to do the opposite operation. So I'm going to divide my A out of all of my C's in those binomials. If there's a fraction, you always reduce, and then if it can reduce to a whole number, I'm left with the whole number. If it cannot reduce any further and I am left with the denominator, here's the name. The bottom comes up to be my new A. Now, Miss Killen, that's really pretty, but I got to see how that's worked. So let me show you. Remember, always look for that greatest common factor first. So what I want to do is I want to take all these steps and I want to work it in this trinomial. Now I have 2x squared plus 11x plus 15. I do not have a greatest common factor. So I'm going to start my bottoms up. I'm going to take my A and multiply it into my C. And I get x squared plus 11x plus 30. Now, I'm left with a trinomial. We've multiplied, and I have x squared plus 11x plus 30. I'm going to find the factors of 30. So the factors of 30, that will add to give me a positive 11. So let's see. I have 30. I have 1 and 30. I have 2 and 15. I have 3 and 10. 4 will not go into 30, but 5 will. So which of these pairs will add to give me a positive 11? Exactly right. So as normal, building those two binomials by using my 5 and my 6. Now, my second operation is an addition. So that means both of my binomials are going to have my first operation and then the factors of x squared. Now, normally we would be done, but we're not, because we started this problem off by multiplying that A into C. So now I have got to take that A out of my C by division. So I am going to divide it back out. I'm dividing what I multiplied, which is my 2. 6 divided by 2 is 3, so I am reducing and getting a whole number. 5 over 2 will not reduce to a whole number, so what I'm going to do is bring my bottom up, and I have 2x plus 5. So I took my trinomial, where my A is greater than 1, factored it, and got my two binomials, 2x squared plus 5 times x plus 3. Check your math, check my math, and see what we've got. Now, how do I know that I did the correct steps? Maybe you're factoring, you didn't get what I got. So how do I know, Ms. Killen, that I did right? All we have to do is FOIL it back. So let's FOIL this back. So we got 2x plus 5, and we got x plus 3. So we're going to FOIL this back. First, outer, inner, and last. Making sure we got that last. Like terms together. So when I FOIL it back, I should get my original problem. And we did. So we know that our math worked. We always want to make sure that our math works. All right, so we FOILed these back. We got our trinomial, so we're good to go. We started with the 2x plus 5 times x plus 3. And we got that 2x squared plus 11x plus 15. So now let's do some practice. We want to use the steps that we've written down to do the following problems. Now, a new way to find factoring. I want us to not be scared of these quadratic factoring because I don't remember my multiplication tables. That's okay. Sometimes I forget, so it's okay. Let me show you. Everybody watch. I am going to pull up my calculator. All right? So let's say that we are factoring these trinomials and it gives me a number that I'm not quite sure what all the factors are. Let's say they want us to find the factors of 20. So what I'm going to do is I'm going to hit my y equals key. I'm going to make a fraction. Second, y equals that n divided by n divided by d. I'm going to put the number that I'm wanting to get the factors of, which is 20, and I'm going to put that over x. So this is how we're finding factors of a number. Once I have that 20 over x, I'm going to go to my table, which is second table. Anywhere you have a whole number in your y1 column, those are factors. So let's see, 1 and 20, 2 and 10, not 3 because that's a fraction, 4 and 5, 5 and 4, and the rest of these are fractions. So I know they are not. Now when I get down here to 20, I've got 20 and 1. So that is how I find factors if I forget maybe. So let's do another one. Let's go back to my y equals, and let's say I need to find the factors of 24. I put that on my top or my numerator and go to my table, and then here are all my factors. Remember, when my y is a whole number, that's a factor. So I've got 1 and 24, I've got 2 and 12, 3 and 8, 4 and 6, 6 and 4, 8 and 3, and it repeats itself. Okay, Ms. Gillen, those are ones we've used. What if I've got like a big number? I'm glad you asked. Let's go back to y equals. Let's put in 124. Whoa, that's a big number. Let's go to our table, second table, 1 and 124, 2 and 62, 3 is not, 4 and 31, 5, no, 6, no, 7, no, 8, 9, and 10, 11, 12, 13, nope, none of these. So we can see as we go down this table, if our y is not a whole number, it's not a factor of what we're looking for. 31 and 4 are. So this is a new way for us to make sure that we are getting these correct factors when we're having to find them to multiply to get these new binomials. So I wanted to make sure that we all understood how to use this feature of our calculator. So let's go back. So now that we found this new way, let's take that and put it into some practice. So I'm going to do these. You're going to do these. I'm going to do the first one, and you do the first one on your page. And then when I'm done, I'm going to turn around and we're going to talk about it. So you go ahead and work it. I'm going to work it at the same time and see what we get. So let's go. So I don't see my greatest common factor, so I'm going to multiply my a into my c, and I have x squared plus 3x minus 10. I'm getting the factors of 10 that will subtract to give me 3. So I have 1 and 10, 2 and 5. I can use these two. I build my two binomials. I'm going to have one that's positive and one that's negative because my second operation is subtraction. Positive 5 minus 2 gives me 3. I have my x and x. Started out by multiplying, so I'm going to divide out. I cannot reduce 5 over 2 to get a whole number, so my bottom comes up. So I have 2x plus 5. 2 divided by 2 is 1, so I have x minus 1. Okay, what did you get? I got 2x plus 5 times x minus 1. What did you get? Did you use the same factors that I did? Did you have one binomial that's positive and one binomial that's negative? Did you make sure that you brought that 2 back up? Because I could not reduce that 5 over 2. Good job. Let's do number 2. I do not have a greatest common factor, so I'm going to go ahead and multiply my a into my c and rewrite. I'm going to get the factors of 12 that will subtract to give me a positive 4. So I have 1 and 12. I have 2 and 6, and I have 3 and 4. Now, which pair could I subtract to get a positive 4? Yes, 2 and 6. So I'm going to go ahead and build those binomials with my 2 and my 6. Now, which one's going to be positive and which one's going to be negative? I want to subtract, so I have a positive 4. So positive 6 minus 2 gives me 4. And then I have my x and x. Started this problem off by multiplying that a into my c, so I want to take it back out. So here's my 3, here's my 3. 2 over 3 does not reduce to a whole number, so my bottom comes up, and I have 3x minus 2. 6 over 3 does reduce, so I have x plus 2. All right, let's look at number 3. First, always look to see if I have a GCF. I do have a GCF. So do I have a GCF? 4 and 21 and 20? No, I don't think I do. No, so I don't. I can't. So then I'm going to go ahead and multiply in. I guess I misread it. That's fine. So I'm going to rewrite my problem. Whew, Miss Killen, that's a big number. Remember what we did with our calculator. I went and I found my factors using that different feature that we just learned. So I need the factors of 80 that will add to give me a negative 21. And what did we find? 5 and 16 will, right? So then I'm going to build my binomial. I have a 5 and 16. My second operation is addition, so both of my binomials is going to be that first operation. Then I have my W and W. I started this problem out by multiplying my A into my C, so I'm going to divide it back out. 5 over 4 does not reduce to a whole number, so I'm left with bringing my bottom up, and I have 4W minus 5. 16 over 4 does reduce, so I'm left with W minus 4. Good job. Last one. So I do not have a greatest common factor, so we're going to jump on in to multiplying that A into my C. So I'm going to have f squared plus 17f plus 30. I need factors of 30 that will add to give me a 17. Go ahead and use that y equals feature and pull that table of all of those factors to see which ones we can use. And it's going to be 2 and 15. So I'm going to build those binomials. So I have 2 and 15. My second operation is addition, so both of my binomials are going to be plus. Then I have my f and f. Started this problem out by multiplying that 10, so I'm going to divide that 10 back out. Neither one of my fractions are going to reduce to a whole number, so I'm going to reduce the fraction. Well, Ms. Killen, I don't know how to reduce a fraction. Put 2 over 15 in your calculator. Go to math and to fraction, and it reduces. So I have f plus 1/5. And then same way, 15 over 10, math fraction will give you 3 over 2. We'll give you 3 over 2. So I'm going to have to bring both of the bottoms up. So I have 5f plus 1, and then bring the bottom up, and I have 2f plus 3. I'm going to write this over here so we can have a little bit more clarity. 5f plus 1, and I'm going to have 2f plus 3. Check my work, check your work, and see what we've got. Make sure that my math and your math match up. If you're having problems with those factors, remember how we find those factors on our calculator. So now, let's see what we can do. Now it's time for me to show you what you got. Go ahead and pause the video. work by yourself or go ahead and work with your partners, and let's see what we get, and then come back to me. All right, so let's see what we've got. I'm going to work it. You check my math. Here we go. Do not have a greatest common factor, so I'm going to multiply my a into my c and rewrite x2 plus x minus 30. Using the new feature we found on the calculator, I'm getting my factors of 30 that subtract to give me a 1, which we found out was 5 and 6. So I'm building those two binomials. I'm using 5 and 6. My second operation is a subtraction, so I know that my binomials, I'm going to have one that's positive and one that's negative. So how do I subtract a 5 and a 6 to get a positive 1? Exactly right. Positive 6 minus 5, and then I have my x and my x. I started this out by multiplying the 3 in, so I'm going to divide the 3 back out. So my 5 over 3 does not reduce, so my bottom comes up, and I have 3x minus 5. 6 over 3 does reduce, and I have x plus 2. To make sure that we do the math right, we can always go back and FOIL it. All right, so then let us try our next one. Let's look at number 2. My a equals 1. I do not have a greatest common factor, so I'm just going to factor as normal, finding the factors of 45 that will subtract to get me a negative 12. So when I do that, what do I get? I get 15 and 3. So let's go ahead and build those two binomials. I have 15 and 3. Since my second operation is subtraction, I know that both of them are going to have different signs. So how am I going to subtract and get a negative 12? Positive 3 minus 15, and then I have my x and my x. Good job. So let's look at this last one. Do I have a greatest common factor? Yes, I do. So I'm going to pull out a 3. And what do I have left? I have 3t squared minus 4t minus 6. All right. So then, got my greatest common factor out. So the next thing I need to do is factor my trinomial. So I'm going to multiply my a into my c and rewrite. Remember that GCF is like bad luggage. I'm just going to bring it on down with me. T squared minus 4t minus 16. Nope, that's 18, excuse me. Get the factors of 18. That will subtract to give me a negative 4. And what do I get? Let's see, 18. I got 1 and 18. I have 2 and 9. I have 3 and 6. Can I factor it any further? I can't. So this right here is as far as I can go. Sometimes you're going to get where all you can do is take out a GCF, and that's as far as you can go using the factoring method. So if you get to that point, don't say, oh my goodness, I did something wrong, because you didn't. You just did the only thing you could do with factoring. So don't feel bad, because when I'm working, I was like, oh, nope. We got it as far as we can go with our factoring, so don't feel bad. All right, so let's see what we got. All right, so I want to make sure that I don't forget. I want to know the steps that we use when we factor these trinomials when a equaled 1. And then I also want to remember that our factors when factoring, when our a is greater than 1, and the steps that we have here. Remember, bottoms up, it gives its name. When I can't reduce that fraction to a whole number, the bottom comes up. So that's the whole name. I am so glad that you came to join us today and learn with us here at MPB. I'm Ms. Killen, and have a great day.